the India map here. So it's somewhere I've got it from the kind of foreign organization. So that's where they have this accident, you know, the indicators. So so UN has taken a lot of initiatives to cut down on the accident rate, and there are, and most of the governments are also bringing up a lot many legislations or rules to say that, or to impose some certain kind of restrictions on OEMs like Toyota or maybe BMW, the car manufacturers, saying that you have to abide by certain regulations. When you produce a car, and if you go and hit a pedestrian at this particular speed, then the harm or injuries to the pedestrian should not be um, maybe bigger than certain quantified numbers. And this kind of a guidelines are necessitating the intervention of technology in accident prevention. That is where camera or maybe radar or ultrasonic sensors are playing a crucial role in reducing the accidents. And you must, maybe most of you must have seen that in most of the cars nowadays, even EBA, emergency brake assist, or sometimes it's also called as automatic braking, is common. And in some of the countries it has been mandatory regulation. So car manufacturer cannot sell their car if they don't have this particular feature. So why is it required? Because it cuts down on the accidents so that their lives are saved. So that's the kind of a motivation for autonomous mobility. And then we will discuss all the details, and there are some other motivations, and you can always, we can also discuss that with certain examples later on. And I also have some videos where we can see that why computer vision is so important for autonomous mobility. Um, Please stop and ask me questions, right? Well, there is a international body called as SAE, Society of Automotive Engineers, and it defines different levels of uh, automation in mobility or driving. There are five levels of automation in driving. First one is like no automation. I mean, it's like always driver drives and he applies brake, he accelerates, he stops, indicators, whatever, whatsoever. But there is no other intelligent technology intervention. There's no camera, there is no radar, there are no ultrasonic sensors, nothing. Then there is a level five, which is a drastic automation. It's a full automation. Here you don't need steering wheel. It's like a robot. The car drives. You just need to tell where exactly you want to reach, what are your coordinates, maybe possibly, and then you select that, and then the robot. It's kind of a robot taxi. It picks you up and it drops you there, and it takes care of all those chaos in on the traffic on the road, right? And it's so intelligent, and that is full automation. And what are the timelines for it? Maybe it is not an immediate reality. Sorry, it's not an immediate reality. It will take, um, I think, another 20-25 years maybe to to be an acceptable solution for the consumers. I don't think right now there are solutions. This kind of a full automation systems are available. Even Continental has a solution, and that's called as Cube, where you can get in and then tell where exactly you want to reach, and it will drops you there. but it's mostly the cube operates mostly within our Frankfurt, Germany, campus premises. It's not basically deployed outside that. But then there are certain solutions in London, I think in Heathrow Airport, where they have similar solutions, but some other you know tier one suppliers, and it is mostly used for picking passengers from one terminal to another terminal for just to avoid the time or maybe the cut down on the effort. But it is operating mostly in a controlled environment, right? It's because it's more of a passengers there, people are there around, but there are no complex scenarios, right? When I say complex scenarios, like other traffic participants like cars, trucks, bikes, or maybe uh, kids that are running around. Oh, maybe in airports you definitely have kids running around, but then uh, you'll not have bicycles and things like that, or maybe curved road kind of scenario, or high speed movements. You'll not have in a controlled environment, so it still operates without a hitch. But on the road, I think there's a long way to go. So that's where uh, now technology is working, moving towards. But then you have level one and level two, level three, level four. These are in between levels. The degree of automation varies from level 1 to level 4, but then there is also discussion that level 3 and level 4 are redundant. You can merge both of them together and you can have one level. So there's a lot of discussions which are going around. But if you ask me, where are we right now in these five levels? We are mostly in level 1, and that's because of the legislation. The governments are imposing a rule saying that you have to have emergency brake assist, and that's why all the car manufacturers are forced to embed certain technological interventions. So what it is mostly to do with the traffic jam assist functions, which means that if you're in a traffic and let's say there's a traffic light, a red light, and or maybe it's a slow moving traffic. So you normally what we do is, okay, we stop, slightly accelerate, again stop, accelerate, stop, very slow speed maneuvering, right? So in these such scenarios, there is a function called as a traffic jam assist. You just press the button and say that enable that function, and then you are just hands free. And traffic jam assist function will follow the car and maintain follow the cars in front of your vehicle, and it maintains a lane. It maintains the lane. It doesn't move, deviate away from the lane. So it maintains the car within that particular lane and follows the opposite. The cars in front of your vehicle, and it maintains proper distancing, right? And there's no chance of hitting the car in front of you. Or maybe let's assume that you are driving, and maybe you're driving at 70 kilometers per hour, and there is someone, there is this, maybe there is another car or a truck in front of you, and they've applied brake all of a sudden. So now in normal scenarios, what happens is that you might, if you don't notice that, we might go and hit the vehicle in front of us. But when you have emergency braking assist function, it sees the vehicle in front of you and it maintains the distance. And if you get close, and it will apply brake all of a sudden. And it applies brake such that you don't deviate or move away from the lane, maintaining all uh, you know the moment of inertia or physics and everything, and it maintains the it avoids the accident collision. So these kind of functions are kind of a legislation, part of a law now, and that is level one. So it's mostly with your longitudinal movements. But then we have a level two is much more than level one. But here you can change the lane without any manual intervention. So you just you just go for autopilot mode, and let's say that you are driving a highway, so you're hands free, and then there's a slow moving truck in front of you, but you want to overtake. So the vehicle will decide whether what is the right time to overtake. So it will overtake and it will come back to the lane, or it takes all those decisions on its own. So it's along with the longitudinal movements in level two, you also have bit of lateral movements. That's basically changing the lanes kind of a features, and that's partial automation. And then level three, level four is much more than that, where you can basically exit the highway. You know, the the car takes the decision if you, or maybe you just set your destination, and car chains takes a decision, most of the decisions for you, right from you know driving on highway, emergency braking, changing the lanes, or maybe parking. You just go home and then you just say that okay, go and park. So your car on its own drives and parks itself in within the garage. Or maybe you go to a shopping mall and you just get out of the car and then they say that okay, so park yourself, and the car goes around and finds its place for itself, and then it parks on its own, and that too beautiful reverse parking. So I have a video later on. I'll show you all of those some of those these features from Continental. So these are the kinds of levels, different levels, and that's where a lot of innovation, research, and development, and of course industrialization of this research is very very important. Because if you have to reach level three, level four, and also level five, it's important that we pursue research within these topic areas so that this research can be productized. And when I talk about level one and level two, again, there are a lot many shortcomings. There are a lot many solutions now. Different tier one suppliers. See, these tier one suppliers supply solutions to automotive companies like Toyota or BMW or maybe Volkswagen or Audi, right? So they are the car manufacturers, but the tier one suppliers like Continental or Bosch or Veoneer, and then there is Aptiv. So these companies basically focus on R&D on these topics, and they come up with the algorithms which satisfy the needs of these levels of driving automation, right? That's about it. So now let's move on to some historical um, underpinning behind this technology. So the concept of all of this automation and the mobility, the technology intervention started way back in 2004, or maybe even much prior to that. Well, maybe it's worth showing a video to start with, uh, just to show something from Carnegie Mellon University, right? Okay, keep listening. I will explain later. Okay, so that was NavLab. Now, what is so important about this NavLab? It's developed by Carnegie Mellon University. I think it was prior to 2000. They have developed. So they were the first one to pursue research in autonomous or autonomous mobility. They developed this robot taxi, and you could see that it was moving very slowly, and it was full of computers inside, and it was producing a lot of heat also, it seems. And that was one of the first versions or experiments that was conducted by Carnegie Mellon University, and they were doing very well uh, in this particular topic. But again, very high-end lasers and kind of radars, and also they were using um, high-end cameras to do some kind of a perception, scene understanding, and that's how it has started. And later on, DARPA is a U.S. defense agency. I think most of you are familiar with the DARPA because DARPA plays a crucial role in furthering the research, uh, maybe any topic, right from computer science, electronics to physics, mechanical, in almost every area. DARPA has contributed significantly because these are the guys who always wanted best of the technology for U.S. defense agencies, and that is where they used to fund most of the research activities across universities or maybe in public domain. And eventually DARPA got interested in this autonomous mobility topic, and they announced a competition in 2004 that, guys, you have to drive autonomously around 150 kilometers, and that in Nevada, a desert area, I think Moby Desert area. And the price was 1 million US dollars. Okay, and it was very interesting for most of the universities and also some of the um, autonomous or maybe vehicle manufacturers, car manufacturers. So they many of the university tied up with uh, various car manufacturers and competed in 2004 competition, and but nobody won because nobody cleared the 150-kilometer grueling road drive. Carnegie Mellon University did, I mean, they were far ahead of others, but still their kind of a robot taxi failed to cross the destination or the final line because they had certain mechanical failures or things like that. Um, and then in 2005, DARPA again announced a competition, and they said that we will give you double the amount this time. So we'll give you $2 million, and the kilometers is 212 kilometers. So that's they've increased the distance, but then again they changed the route. They so this time it was in California, and it's off road. It's not on the road because anyway, none of the governments will give permission to run a competition of this scale on the road. So they had to opt for off road, and the track or the road, the actual path was kept secret. So they told all the participants, there were around 20, 22, or maybe around 25 participants, and they told all of them that be ready. And this is the concept. We'll give you the starting GPS location and end GPS location, and we'll also give you the in between coordinates. Now you just have to see the road and drive on the road, and it completely autonomously, no driver whatsoever. And then, well, Stanford tied up with the Volkswagen, and they used Volkswagen Touareg. That's what you see here on the screen, and they won the prize, and they were the first one. They took around 6 hours 54 minutes to clear the competition. Carnegie Mellon University, they came second, and they were around 10 minutes late than Stanford University. And there was a lot of rivalry between Stanford and CMU, Carnegie Mellon University, because the guys who were part of Carnegie Mellon's research, autonomous research, joined Stanford, and these guys actually won from Stanford. So there was a lot of interesting rivalry between both of them. But then, and that was one of the pivot moments in autonomous mobility, because once Volkswagen Touareg succeeded driving 200 kilometers autonomously, then a lot many car manufacturers started looking at it, and then the governments also started looking at it. United Nations started looking at it, and they just started looking at it from a different perspectives, also from social perspective, the benefits of the technology to the society, and how it can reduce the accidents. And that is how the journey started, right? And probably I can show you a video of the Touareg. Maybe I'll just all right. So that is Touareg, and you could see that from the first vehicle nobody got down, right? And the second vehicle was basically DARPA one, and they were kind of a part of this competition, and they were the decision makers. They were following it. Well, so that is how the journey started. And the Stanley is the name of the vehicle, and I think it's still in display in US. I think it's display in Stanford. All right. I hope you can also see the videos and hear the audio, right? Because it looks very monologue. Um, can you guys actually hear the audio and video properly?
Yes, sir. Yes, sir.
Okay. All
It's
right.
fine.
Fantastic. Okay. Yeah. Please stop and ask questions. Otherwise, it might get bit boring, right?
Sir, I have
Yeah.
a question if I can
Oh,
interrupt you here.
sure.
Okay, I'm Shrikant, and you had mentioned that in level 5 autonomous navigation, the vehicle
Yeah.
tries to apply emergency brakes in case of
Hmm.
a dangerous situation. Okay,
Right.
now
Mm-hmm.
given that we are having a driver with a psychology, a
Mm-hmm.
typical driver psychology present there in the car, and the
Mm-hmm.
vehicle applying brake all of a sudden without his notification,
Mm-hmm.
will that not cause more panic and cause an unintended accident
Mm-hmm.
immaterial?
Okay. Yeah. Well, so the vehicle applies brake even in level one, right? And the functionalities like emergency brake assist can trigger a brake in level one. We don't have to go to level five. Now, well, that is a important question, and that's where like human or acceptance is also required because people might, first of all, someone might get uncomfortable to drive this kind of cars, right? Without really, if he feels that this car is unpredictable, it applies brake, it changes lane on its own, or it behaves paranormally, then he might get really uncomfortable. Yes, you to your question, applying brake all of a sudden, and then passenger behaving uh, maybe in a panic or anxiety, leading to accidents. Yes, it's there is a probability, all probability. That's where technology is also being involved to cut down this kind of driver behavior under these circumstances. Now, the problem of driver anxiety or driver behavior to a emergency braking scenario has to be looked at in multiple perspectives. Now, car doesn't apply all of his braking all of a sudden. Let's assume that if there is a child crossing the car road all of a sudden, or a dog, or maybe let's say that there's some bicycle or maybe some other car in a T junction, right? Um, in such cases, if car has to apply brake all of a sudden because to avoid the collision and to save the life of maybe a bystander or a pedestrian or a bicycles. So in that case, yes, it is required to apply the brake. But then, if let's assume that there's a car, there is a truck malfunctioned and it's parked on the road highway, and driver did not know, have has not noticed it, but he is driving at let's say 100 kilometers hour per hour, and if he's reaching that particular truck from behind, and then car sees it like let's say 120 meters away, and it gradually slows down, so it doesn't apply brake all of a sudden, right? So it's a smooth transition, and then maybe it will come to halt or maybe it will change the lane depending on the level of automation within that car. Yes, there are a lot of research, and also there are a lot of publications. If you go to some of the eminent databases, you will find on driver behavior. and then driver acceptance of this technology of robo taxis. So your question is very much valid, and accepting this technology and changing our approach to driving is also one of the studies of many of the psychologists and policymakers are actually studying this topic, and that is extremely important to take this technology or embrace this technology also. When people understand the technology better, then they will use it. Maybe I'll give some more examples as I go forward with some example, some videos. Hope I answered your question.
Thank you, sir. Yes.
Yeah. All right. Okay. So now the next topic is uh, the the sensors itself. So prior to sensors, maybe I just want to explain you or maybe give you a slight overview of what are the functionalities uh, that is a part of ADAS or autonomous driving. There are two branches of the technology. One is ADAS and the other one is AD. ADAS is Advanced Driver Assistance Systems. These are basically functions which are assisting the driver. So they don't take control of the car. Uh, just to um, help the driver to take the decision. And that is why right now we are more, I mean, the technology is heavily focusing on our uh, ADAS, Advanced Driver Assistance Systems. But then there is another stream, which is autonomous driving. We call it as AD. And AD focuses more on how do we drive autonomously without driver. So the driver is not the real focus, but in ADAS we develop functions to support the driver in his decision making, right? uh, some of the functions are listed here. I believe some of you have already seen this, some of these features, like I think ACC, adaptive cruise control, or AEB. I mean, there are different nomenclatures here. There is something called as autonomous emergency braking. I call it as a IBA, uh, emergency braking assist. So the nomenclatures are different, but these are all the same. And then blind spot detection. Sorry. ACC, I hope everybody knows, is a cruise control. You just press the button on a highway and it will cruise, right? And it will increase the speed, decrease, changing the gear and everything it takes care of. Braking, emergency braking assist is basically if there is a hazard on the road, and if it is going to lead any accident or collision, and to avoid that, this emergency braking assist function uh, can play a crucial role, and it can save a lot of lives. And then blind spot detection, and this is extremely important when you are changing the lane. uh, so basically the cameras can detect if there is any vehicle in blind spot region. And then there is forward or rear collision warning systems, basically to avoid the accidents, and intelligent parking assistance, which, as I told some time back, that you just press a button and it will find the place for parking itself. And then there is a cross traffic alert, extremely important feature. Um, it's like, let's say that you are parked your car somewhere and you want to now enter the road, get out of the parking and get into the road, right? And in such scenarios, there may be lateral moving vehicles or some pedestrians or bicycles, any traffic participant. In such case, situation is important to identify if there is any traffic, oncoming traffic. which might lead to accident. Sometimes we might, as a humans, we might make some mistakes. We might focus on mobile or some message, WhatsApp, whatsoever it is, or maybe live stream some videos. In such situations, um, in T junctions especially, there may be some um, issues, and that is where this cross traffic alert function is really, really useful. And I think there's a bit of noise in the background. All right, thank you. And then there's a lane change assist, and this is really required for uh, changing the lanes if you are having autopilot, and then this kind of features are really required. Now, and also you can see that there is like lidar, radar, camera, not many sensors are mentioned here, and then there is ultrasonic sensors and so many things, right? And this is what these sensors gives you the inputs. The input might come from radar or maybe lidar or camera or maybe ultrasonic sensors. Different sensors work in different bands. You know that we camera work in RGB, the visual spectrum, and then ultrasonic, it has a lower range, but it maybe it is a cheaper sensor. Maybe it is useful to detect some objects which are in the close range. Radar has, depending on the capacity of the radar and the cost of the radar, it has a range from like maybe 40 meters to 150 meters, maybe. And LiDAR also has a similar range. And of course, camera, we know that you can have, you can build cameras for, I mean, for a very good range, but then cost varies, right? Because the design, the optics, all these things cost. But every car manufacturer wants to have a best solution at a very low cost so that he can sell the car to in the market. If the car is too costly, I think nobody is going to buy it, buy such cars with such features, because again, there's always a trade-off. The features, the safety, and also the cost. If a car comes with the high safety standards and also maybe luxury features, some of them these are luxury features, then I don't think many people are interested. So in that cost, there is always a trade-off with the features and then the cost. So all the tier one manufacturers, companies like Bosch and Continental or Aptiv, so or even a Mobileye, there's a Intel subsidiary, Mobileye, they focus on manufacturing the sensors with low cost sensors with smart algorithms. So, and then they deliver the best of the features to the car manufacturers. So maybe I will show, before I get into the further discussion, maybe I'll just show one video of parking. Um, well, so maybe, okay, so here is a car. It's a Continental car. It's a kind of a demo car. Nobody is inside the car, and it will now pick a spot, empty spot for parking. So let me play it from the beginning. And it is definitely triggered automatically from people who are far away, right? So let's see. So it's no driver. right? So this is about automatic parking. Now, how does it work? Well, lot many sensors are involved. We will discuss that later. And maybe I'll also like to show lane departure warning. Okay, there's no audio here, but you can see that. Okay, there is no audio. Yes. Now, as someone asked me a question, right? Um, that the kind of a behavior of the vehicle sometime, and especially when it is when LK is enabled, lane keeping assist. This kind of functions are involved, and it the driver might feel strange, and it actually happened that some of the drivers were saying that okay, the car really behaves crazy sometime. What happens is that as they drive, if they are getting very closer or stepping on the lane or driving over the lane markings, then it nudges them. Sometimes the steering wheel vibrates, or sometimes it might vibrate and push them back to the lane, and it that might result in some kind of a chaos. But then there are certain manuals, and then proper instructions are given to the driver so that they are aware of the functionality of the car. So if somebody is not aware of these features, then they might feel crazy, and then it might result in some, you know, um, quick unintended behaviors from the driver, resulting in some accident. It might even happen. But then these are safety features, and then the knowledge of the driver is also extremely important, right? And sometimes somebody might doze off on the wheels, and then if they are moving away from the lane, and that might lead to accident. And in such cases, this lane keeping assist really helps, right? Well, now coming back to the sensors. Now, what are the sensors? So there are like combinations of sensors: radar, lidar, and also ultrasonic sensors. And where is the technology going? So technology is moving towards the sensors which are low cost sensors. Now, what are those low cost sensors? Basically, the low cost sensors uh, are. Is there a lot of noise from my side?
No, no, sir, it's clear actually.
Okay, all right. Okay, so the low cost sensors are basically camera sensors. Camera has a lot of advantage, and that is where computer vision has a lot of scope for research in this topic, because cameras are a bit cheaper compared to, I mean, very much cheaper compared to lidar, and it is definitely cheaper compared to radar, because considering the capabilities of radar and also the capabilities of camera, ultrasonic sensors definitely has a very limited scope. So the best solution is always, I believe that it is always a camera. Now that is where, if you know, Tesla is also working towards. Tesla said that anybody who thinks that lidar is the solution for autonomous driving or ADAS, and he said that they are daydreaming because he believes that camera and computer vision can turn the tables in autonomous driving or ADAS. Why? Because technology and algorithmically we are improving day by day, and that is where the success lies. I mean, like if you come up with a real smart cameras and smart cameras and also uh, smart algorithms, and the combination of these two can change the game. Right now, if you look at Google, Google has a autonomous driving project called as Waymo, and Uber also has it. Uber, I think, has joined with Aptiv in the US, probably. I'm not really sure. But Uber has definitely has some collaborations on autonomous driving, but then most of these companies are heavily focusing on lidar. Definitely, there must be some business strategy behind it, but in the long run, I think I strongly believe that camera has a edge over other sensors, and computer vision has a key role to play in all these technologies. Well, now mostly, or maybe in general, uh, there's a suite of cameras and radars and lidars here. You can see that um, there is a emergency braking, pedestrian detection, collision avoidance. For this particular purpose, you definitely need a camera. And also, if you're focusing on adaptive cruise control, you need radar, but not just radar, but then it's a combination of radar and also camera. But then if you want to also look into the surrounding of the car, because you also need to know what are the blind spot, who are, or what are the other vehicles, or are there any other vehicles parallel to your own car, or what is going on in the nearby, or can I take reverse? Then you need a rear view camera, or maybe you also need ultrasonic sensors, or you might need radar as well, because the more sensors you have, it brings a lot of redundancy, and redundancy is good because it's like you hear the sound and you see something and you smell something, so it's like multiple perception sensors will strengthen the decision making. But again, multiple sensors will also increase the cost, right? So any addition of sensors is not desirable because it will increase the, I mean, cost, right? So we have to achieve better performance with limited sensors, but for different features to be enabled, as of now, I think people are going for radar and camera combinations, because all of these functionalities are not enabled in all the cars. Most of the time, car manufacturers are going for meeting the minimum legislation as of now. And as and when the legislation becomes stronger, that means the governments impose rules and restrictions on selling the cars, imposing safety criterias, then I think most of these functionalities will be enabled. For example, parking assistance. It's a kind of a, maybe it's a kind of a comfort feature, luxury feature right now. So maybe luxury cars like Daimler, Audi, they're going for this kind of a features. But it is not really a necessity. But if you want to enable this feature, definitely you need at least um, camera based solution. But if you want to make it really stronger, you might even go for radar as well. But then lidar is really costly. Lidar has not really picked up except for experimental purposes. Well, I'll just now little fast track because we have half 30 minutes more. Well, so this is how the combination of camera looks like. Here we saw the functionalities, and here the camera combinations. You can see that if it is surround view, then you need at least 4 cameras with different configurations. And if it is a rear view, that means for let's say parking or taking reverse. If there are any objects in the back, then the rear view functionality can see it and apply brake, or if there is any pedestrian and then or a child, so it can see and then detect a pedestrian or a child, and then it applies brake, saving life. And then maybe in ADAS or maybe in autonomous driving, we definitely need around 7 to 8 cameras, right? And the number of cameras here are just a guideline. It all depends on the uh, specifications of the camera or configurations of the camera. What is the uh, range, or what is a field of view? What is a resolution? It all depends on that. And the design of the cameras play a crucial role in choosing the number of cameras to cover the entire 360-degree view, and also considering the functionalities, right? So if you have a very narrow field of view camera, then the distance it covers increases because it's a narrow field of view. And that kind of narrow field of view may be required for functionalities like cruise control, where you need to you know see a longer distance, because if you're driving in 60 kilometers per hour, and if you have to apply brake, then you have to see certain objects beyond 100 meters, and then you can comfortably brake. You need few seconds to come to a halt, or maybe to slow down. So depending on the functionalities, the design of the cameras are done. Well, so first level is all about perception. That is, you need a sensor, camera, radar, lidar, or maybe ultrasonic sensors. And then there is a school of thought, that is a fusion. Okay, what is this fusion? If you have a radar, you take the data from radar and overlay with the images, and then you and then do the processing, and then develop your algorithms and take a decision, and and maybe you will have a system response. And this fusion can happen at a raw data level, right? At a pixel level, or maybe at an amplitude level. And that is one way of doing a fusion. And not many people are interested in this raw signal data level fusion, and then developing algorithms on top of it. And there is a second school of thought, that is like, you do the camera processing, you do computer vision, and take a certain objects or some kind of a decisions, and you do the fusion of the decisions from radar, decision from camera, and then you take a final uh, decision or a final reasoning, and then that will become your system response. For example, in radar, you can see that if there is a car in front of you, basically you can detect accurately what is the distance, and you can see the radar. Sorry, you can see the object, and in camera also you can see it. So in camera, using computer vision techniques, I detect the object, say that there is a car, and now radar also says that there is a car over there, and then I fuse the decisions of this, and then I finally conclude that, okay, probability of uh, having a car at 100 meters is very high. It's a 90% probability, right? And now this is a good decision because I'm making a decision with very high probability. But sometimes, let's say that we are very blind in night, isn't it? Computer vision, camera, we don't see anything, right? But then radar can penetrate in the darkness, and radar can say that okay, there is a car, still there is a car. So, but then camera doesn't work. In such these cases, you definitely need fusion because camera has its own limitations. It doesn't work in some extreme weather conditions or maybe in night scenarios. So in such cases, definitely radar and camera fusion is, or maybe lidar fusion is crucial. And these are the different levels or maybe steps in providing the system response. Now, if you look quickly, let's look into the different solutions. There is a camera that's in gray, and then there is a radar here, and then there is a lidar. And what does this graph say here? It says which one works under what circumstances. So we have different parameters here. Distance measurement. Camera is so poor in distance measurement, right? The inner gray area. Whereas radar and lidar are too good in distance measurement. In the sense like if there is an object at 100 meters from using computer vision techniques, it is extremely challenging to say that what is the distance, and it may be slightly easy if the object is not moving. If it is static, maybe we can comfortably say that, but if the object is moving, and it is extremely difficult. And if it is laterally moving, it is a forward moving, backward moving, and these situations will only complicate the scenarios. That is where right now a lot of engineers are working or researchers are working on how do we estimate the distance of object, moving objects or a static object, or how do we come up with one solution, one smart algorithm to measure these distances. And because that distance measurement is extremely important in autonomous driving, because you need to tell how far is that particular car is or truck is or a pedestrian, right? And since we are bad in distance measurement, we are also bad in velocity measurement, right? Because distance and velocity are related. Now, if our velocity measurement is bad, then we can't say that uh, probably when are we going to collide with that particular vehicle if you don't apply brake. And these measurements are important in ADAS or to enable this emergency braking assist functionalities. And in darkness also, camera is bad, but radar and lidar are good. Weather, not so good, but only just because of the coloring, the texture. We are, or when I say we, as a camera or computer vision, is fairly or very good in object detection, but radar is pretty bad. Or lateral resolution in the sense moving left to right cases. Uh, it is camera is not so good if the lateral movements are leading to a lot many issues. So whenever certain things are bad, it also provides an opportunity to research and work on these topics and provide better solutions, right? So these are all, each of these areas are kind of research topics where various research institutions and organizations and also researchers are working on how do we improve the performance of the camera using computer vision techniques and still estimate the distance measurement. The day computer vision pushes its boundary beyond these levels, and then believe me, camera will play a very crucial role, and it will replace probably other sensors because lidar is damn costly. It is not a viable solution for ADAS or autonomous driving market, and it lidar is not meant for consumer market because probably you can purchase a car with the cost of the sensor itself, so it doesn't make any sense. Maybe it is suitable for some other application. Definitely it is, lidar has a lot of features, but not meant for, not really meant for consumer market. But radar, yes, it is good. Look, you can see that. But then when you fuse with camera, it becomes really good. But still, radar is a bit costly compared to camera, and also object classification is I mean, here maybe it's an error, but it is not really good. Object classification is really good when you do it with the camera. When you fuse camera and radar, it becomes good. But otherwise, since radar doesn't give you the texture or maybe the color information is really important information, and you can do lot many decisions based on that. And if you say that you want to do a sign recognition, you cannot do it with radar. Radar will only say that okay, there is a board over there, that's it. Probably there is a board, but it doesn't tell you what it is, and that is really required, right? If there is a stop sign, you need to read it, and that is where you need a camera, and you need optical character recognition as well, because you need to read each of the characters and make a meaning out of it, and that's where camera is really important. So I request all of you to look into some of these topics and pursue these topics. But we are not so good as of now as it appears, and these are some of the accidents that has happened in recent times, um, through this autonomous, I mean, programs. I mean, ADAS or advanced driver autonomous driving programs or projects. So whatever you see here are the companies who are driving these initiatives. Waymo is Google, General Motors, and then there are a lot many companies. Even Apple is driving autonomous driving uh, program. Toyota, of course, is understandable. Now you can see that who has caused how many. So sorry, there's no access information here. So now this bar represents the accident, number of accidents that has happened or attributed to this project. There are 29, 11, and 4, 1, 1, 1, 1. Well, these are indicative numbers, says that as they drive on road, which is filled with the normal traffic, they have encountered, even though there are like lot many drivers, they have still encountered accidents. So which states that there's a lot many things to achieve. There's a lot many robust algorithms are required, which uh, which understands the complicated scenarios of driving and safely maneuver, right? And that is where a lot of research is required. And you can also see that some of the top companies are focusing on it, including Apple. And it also gives an indication that if they are focusing on these topics, it means that this topic really has some advantage or some benefit, or it is going to grow. It is also said that one of the reasons why computer vision has picked up in recent times is due to ADAS or autonomous driving, because there is a real investment for research or money here in this particular area. The moment industrialists or the car manufacturers see that there is a real money, then they will invest a lot of money on R&D. And that is where you see that there's an increased number of programs, and there are so many companies working on these topics. All right. In India, also there is a scheme called as a Bharat New Assessment Program. What do they do? Now, just like other countries, there's a program called as New Car Assessment Program. There is a EU New Car Assessment Program, Japan New Car Assessment Program, and in India in 2000 around 2019 or not 1917 they have well I think in 17 they started discussing about it, and later on they've started implementing it. So there is a new program. What do they do? They assess every car for its safety levels, and ADAS or is also part of it in a way, because they check, they test hitting a dummy pedestrian and under various situations. And here the technology really helps them to get 5 stars. If it is a 5 star car as per the NCAP or Bharat New NCAP, then people are there is high chances that people will buy this kind of car. So now there is a kind of interest, at least in EBA, that is emergency braking assist, from the vendors or from the car manufacturers like Mahindra or Suzuki. So they are really focusing on this kind of features. Sorry for this. Okay. Well, now this actually shows. Maybe I'll move pretty quickly. It only shows that what is the percentage of cars which are having this the safety features. I think this data is from US. Basically, 47% of the cars had emergency brake assist and crash mitigation features, and it only indicates that very few cars are really having this kind of advanced features. But within as the years are passing, it is becoming really important for even car manufacturer to have this kind of features. Now let me quickly go through some scenarios. I have some 3 scenarios to show to tell you that there is a scope for research in computer vision to further the algorithm development. And maybe if any of you are interested, and definitely you can pursue these topics. Sign recognition is one of the features in ADAS or maybe in AD. Well, true positives everybody knows, and 100% or 99.9% true positives are expected in real scenarios, right? And also how at what distance you do the um, at what distance you do the uh, detection. First detection is also very important, because you don't do the detection in 50 meters, may not be really interesting, but you have to do the detection, first detection of the sign, and say what exactly that particular sign is, maybe at 100 meters distance, right? And that is why it is extremely important. Oh, well, so one is that detecting, and then there are always an issue with the multiple true positives, right? Only one sign, but you have this ambiguity. And there's a lot of research has to get into this area, but well, that's also important, because these kind of scenarios will happen due to the environmental conditions, maybe, or maybe due to the background ambiguity in gradient, maybe, right? And of course, as we all know that always a false positive should be very less, and there shouldn't be any false negatives. There should not be any missing ones, right? There are certain signs here. There's a stop here. There is a give way sign here, right? And these signs are not at all detected. Very challenging orientations, or also maybe a background. So we missed it. Now, how do we develop algorithms despite the orientation? Still, I can say that is more or less is a stop or maybe the yield sign. Then how do we enable similar kind of detections using very smart algorithms for automotives, or maybe it is smart. Why do we say that is a smart? Because you cannot design or develop algorithm which runs on PC but not on the hardware, which means that you will have only 3 milliseconds, or maybe let's say 5 milliseconds or 10 milliseconds to of runtime on a hardware. So the complexity of the algorithm is important. I think we all have studied complexity, algorithm complexity, right? Out of n square on n log n, or whatsoever it is. So the complexity of the algorithm is important. So you cannot have a very high complex algorithm which takes a lot of time to execute, and then it detects these signs, and you have zero false negatives, but then you cannot put it on the hardware. So you need a very lightweight, smart, intelligent algorithm which can be ported on the hardware, and that is actually a challenge, right? Because of the you don't have a runtime on a hardware. See, whatever you see here on the screen is a smart camera from Continental, and it just this has processing power. This camera doesn't have a processing power. It's only a capturing device, and then through the cable here, you can give it to something called as a ADCU, processing unit. Whereas here in this smart camera, it captures the images and the processing also happens here. And is so you have a very tight budget. So it may be the dimension may be around, like, let's say 7 to 8 centimeters width. That's all. Is a small device. Um, and also there is a lot many challenges on, like, on the signs, right? Um, so you can say that these two are different signs, but most of the time they are detected as similar ones because they look alike. So lot many research also go into OCR, optical character recognition. You need to detect each of these symbols or characters and say that what is it, and then use that information to detect the sign itself. And when you see it from 100 meters and through these cameras are not really high resolution cameras because of the cost, and we want to cut down the cost. So these cameras are maybe like 1.2 megapixel with 52 degree field of view. So it's a challenging topic, right? And how many of you have heard about Uber accident, which happened a few years back, 2 years back, in the US? And what happened was the driver who you see on the screen, and she was driving. She was testing the car. The was testing the car. She's a test driver, and she's a qualified test driver. And they were testing the car in the night. I mean, they drive millions of kilometers to understand the behaviors of the car or performance of the car. So what happened was that you can see the interior camera. They fixed the interior camera, and she was live streaming probably Netflix or Amazon Prime or whatever it is. She was something live streaming. So she was distracted. She was looking at her mobile phone. All of a sudden, she realizes that there is a pedestrian and a crossing pedestrian, and and you can actually clearly see that. See, there's a lot of So this area is completely dark here, and there's no light. And even like as humans, probably we could see, but from the camera you can see that there is no pedestrian at all, and this road is itself is like unclear. But then radar could should have helped here, so we don't know what went wrong. But then too close. If she was alert, she could have maneuvered. She could have somehow changed the lane, and she was testing a particular function, by the way. So she should have been alert. She could have changed the lane and saved the pedestrian, but that did not happen, and there was a fatality. Right? So these kind of scenarios are highly, highly important. Uh, right? So it ended up in tragedy, and last week, I think last Tuesday or Wednesday, the U.S. court uh, said that the test driver is guilty, and even though she pleaded not guilty, and now the case is going on, but they said that she is guilty. So why am I showing it? It is important that we develop algorithms which are foolproof, and that is where, even though there is a darkness, and there was ambient light, and if the computer vision algorithms were strong enough, probably they would have detected this lateral movement. But the problem with camera is that it is blind in the night, and it is bad in lateral movement objects. Anything which is moving horizontally in front of you, it is bit uh, bit bad, and we are bad in measuring the distance as well. But the radar is good, but this car is fitted with radar, but still it did not perform. Right. And then I would like to show one more video from this is from Tesla Model 3. You can see the car driving, and there's a person here, and then it collided. There was a toppled car, toppled truck, and Tesla car was in autopilot. It uh, for some reason whatsoever, that car which was supposed to see the toppled truck did not see the truck at all. It went and directly hit face on. Now what happened wrong with that? Maybe if I can go here, see, now the car is approaching, right? And the person whoever you see here is a truck driver. He's telling other drivers that, now hang on, deviate, stop, and all those things. So he was trying to stop all the cars. So Tesla did not see him at all or slow down. And the problem with this truck is that the truck also had uh, white, covering. I think I can show you somewhere. Okay, I think. Okay, let me play it again. See, now the Model 3 is approaching, and there's a truck here. It is a curved road, and the driver tries to stop. It doesn't see, and bang. Right. Now, if you clearly see the video in high resolution, I don't have the high resolution. The problem is that it is a curved road, and there is a elevation also. It's a downward elevation. It's a down basically, and then there is a shadow. So you can see a lot of shadows, and then there is the divider, and the divider shadow is also falling down, and then there was a bridge just before the truck. So this is a very complicated scenario. So in such scenarios, how do we develop algorithms which works irrespective of the shadow, irrespective of the elevation, and understands this white toppled car vehicle. Maybe he failed to distinguish between the road and this white uh, top of the truck. Maybe he thought that it is a road, so he didn't take any deviation. And that guy was an autopilot, and he was not really focusing on the road at all, because Tesla really drives. It drives very well. And this accident happened some 4 5 months back in Singapore, and there are lot many accidents. And then why these are relevant? Because these topics gives us a research topics to solve the problems and propose solutions. Actually, um, I work on computer vision topics, and we meticulously study these topics, and then we improve our algorithms because we do not want to repeat the same mistakes. And the algorithms right now are not really good. I mean, they are good, no doubt, but there are lot many areas where we need to improve. Okay. Well, the other area is that pedestrian detection. The camera is very bad in uh, detecting pedestrians at a close range and estimating how far they are. And this is extremely important because the NCAP programs, I said the new car assessment programs, and also emergency braking assist functions, they need to uh, they need to detect the pedestrian at near ranges and also far ranges. Far ranges camera is pretty good, but in near ranges camera is pretty bad. And since the camera is pretty bad, uh, we cannot have camera only solution for pedestrians. Yes, pedestrian detection. We have to go with the radar, and having again, that multiple sensors will costly. So the car manufacturers cannot go alone with camera. So we need to find solutions so that camera is used extensively by the car manufacturers for their own. Otherwise, they do not get 5 star with camera only solution. So the effort is in this direction to detect the pedestrians in close ranges right now. And is you can go to IEEE or elsewhere, Springer, you will find lot many articles. Please have a look at it. All right. Maybe I'll just go to this topic because we are on time. This is my last slide, and maybe I'll end. So I think I dragged a bit, but then um, last slide quickly. Deep machine learning is the core of whatever I spoke so far. When I talk about computer vision algorithms, right now it is all about deep machine learning algorithms. The focus is so much on deep machine learning algorithms, and the technology is changing every 6 months here on this topic. And the challenge is that how can you have one algorithm or one network which can detect pedestrians, cars, trucks, signs, lanes, and whatnot, even blind or everything around the car using one network. Is it possible? But then you don't have data. Can you do it with the less data? Basically, that deep machine learning algorithms requires a lot of data, and they're pretty bad. You cannot have pretty bad in the sense you cannot have one network. It is highly challenging to have one network which does different um, detections, like when I say object detection in this case of cars or pedestrians, signs, you cannot mix it up together. When you develop a network only for OD, object detection, or only for signs, or only for some other case, it works perfectly. But one network doing all of these things is really bad. That is where we need a single network. There are many companies, startups have started doing it, and in a matter of short time, they have really excelled because of their unique algorithms. And can you have a network with very which works with very less data, and which means that can you also have a unsupervised learning built into these networks because it learns on its own, right? With less data maybe. And then robust performance, no doubt about it, everybody knows about it. Can it also do a prediction in the sense, okay, there is a kid standing there on the road, but he's making gestures to cross the road. Now the car sees it and it understands the situation and it predicts that probably the kid is going to cross over the road. Then the car has to understand and stop. Can you do that with the deep machine learning? Can we also do some kind of a sensor fusion at radar, camera, at a raw signal level? Is it a possibility? People are trying right now. And then there is a hardware related topics. Um, can you develop algorithm which uses hardware accelerators? There are some accelerators available on the hardware, like in neural network related accelerators are available. CNN accelerators are available. Can we use that? And also there is another topic related to hardware, that can you also develop hardware which consumes less power, less heat, more power, more heat. And then if heat increases certain range, then the camera might reset. So these are some of the topics. Um, well, maybe I'll show one video here. That's it. Well, you can go to Google and you can stripe for cube. And this is a cube available in Frankfurt office. It drives autonomously. And it's a very interesting, a robo. And just please go to YouTube and type Continental Cube, and you should be able to see that. And it's an autonomous vehicle, and it stops whenever there's a pedestrians and things like that. You just need to press the destination, and it takes you around the campus. So that's all from my side, and I'm 5 minutes above the budget.
Thank you, sir.
Yep.
If you have any, we'll wait for two minutes. Like if any questions will be raised, I'll let you know, sir.
Sure.
Okay.
Sir, there is one question regarding the ISO 26262 certification for autonomous navigation. Do we
Okay.
have any plan for getting these cars
Mhm.
ISO 26262 certified?
Well, ISO 26262 talks about functional safety, right?
Right.
So yes, almost all the cars are, uh, I mean, it's not fully ISO 26262 standard related pointers, but most of the pointers related to, let's say, ASIL standards, ASIL A, B, C, D, there are multiple standards, right? Depending on the legislation, now car manufacturers are asking for it. Most of the, right now, the requirement is at ASIL B level, and not everything is SLC or SLD. So as per the manufacturer need, which is most of the time is SLB, all the developments are adhered to this SLB level, which is a part of ISO 26262. And then there's the cyber security as well. The hacking shouldn't be allowed. So these things are definitely, as of now, built into almost all the ADA solutions. So we can't really say that ISO 26262 compliant, but then we can discuss the details, like what is the safety level which is allowed. Right now, why ASIL or ASIL C or D is not relevant? Because of the legislation, because the cost of developing such solutions are very high. So since the cost is very high and it is not necessitated by the governments, The governments are not asking for it. There's no legislation. That is why they are going for minimum. Hope that answers your question.
Yes, sir. One last question we have, sir.
Yep.
What about the efficiency during the bad weather conditions like heavy rain or snowfall?
Well, camera performs really bad, no doubt. Heavy rain, slow, dust, early morning when there is you know sunlight directly on the windscreen, or sometime late evening. Uh, this camera is pretty bad, and camera we say that, I mean, camera goes to blockage mode, which means that it goes to under or low performing level. But radar is good in these situations. Certain functionalities doesn't work in these scenarios because camera is for working in reduced functionality mode, but radar works uh, fine. So in while it is raining, you might not get a lane keep assist function. It will it will be off, but you might get object detections because radar and the camera, to some extent, if it is a light rain, still might detect objects around it. So during these situations, yes, the ADAS as a whole works in reduced functionality mode, but camera definitely it is bad. Hope that was a quick answer.
Actually, we have two more questions. I think
Okay,
if you permit me, we'll send you through mail, sir, since we're
sure,
running
sure,
out of time.
sure. Okay,
Yes, sir. Thank
and
you.
yes,
Yes, sir.
I just one last statement is that go to YouTube and search for BEE, and then Continental, and you will see this video. This is a concept video, and it tells you about what the future mobility is all about, and it's done by the Continental, and you can see that, and it's all about the future mobility. Maybe few years down the line, you will see such kind of a mobility. So thank you so much, and have a wonderful day. And if you have any questions, post it, and I'll try to answer as much as possible. And if anybody is interested to work on some of the topics in camera area, some algorithms, get in touch, and we can see how we can enable, even if it is interns or PhD students. Thank you so much. Have a good
Thank
day.
you, sir. Thank you
Thank
for
you.
this insightful session. Thank you, sir. Thank you. Thanks a
Thank
lot.
you. Bye bye.
Uh, as we are left with 4 more minutes, dear participants, we are left with 4 more minutes. We'll continue in the same link with session 5. We have the speaker with us already. Or we can start at 11:50. We'll start exactly at 11:50. Next session will be started in the same link. We'll come back at 11:50. Thank you.